In this tutorial, I'm going to cover how to set up your Rhino file so that we can work more seamlessly in Twinmotion. Now, in my experience, whenever you try to transfer information from one software to another, whether it's Rhino to Twinmotion or pick your software, there's always some kind of drawbacks to it. And we always have to prep a file for that kind of transfer because it never really transfers quite that smoothly. Doesn't matter which software, that's just what it is. These softwares speak different languages, so we have to prep them before transferring. We have to know what the issues are moving forward. And with Twinmotion, coming from Rhino into Twinmotion, there's one big issue that we have to address in Rhino, and that is that Twinmotion cannot apply materials to a single face surface. It could only apply materials to three-dimensional geometry or to poly surfaces. So what exactly does that mean? Here, let me close this out. So here I have my model. If I go into rendered view, okay, we can see, let's take a look here. You see how this wall has an exterior material, which is this kind of bluish gray, but on the inside is a white paint, right? So we have two different color on the walls, on one poly surface, on one geometry. So we applied two different materials. We applied the white color and we applied this color, but it is only one single three-dimensional object, right? The same thing here with this roof. We applied a roofing material to the top portion, but within the same geometry, we applied a color. That is something that Twinmotion cannot do. Okay. So everything needs to be kind of its own individual object. And so that's what we're going to have to do with our Rhino model before we go into Twinmotion. So we do have to spend a little bit of time prepping the Rhino file. But if you spend the time now in Rhino, it's going to make the process so much more seamless once we go into Twinmotion. Okay, so here are the rules. With Twinmotion can only apply materials to three-dimensional objects, okay, three-dimensional poly surfaces, or surfaces that have been Boolean unioned together. So we could have two surfaces, but if they're Boolean unioned, not grouped, not joined, but Boolean unioned, then it'll connect those two surfaces together, even though it's not three-dimensional. Okay. Or the alternative is that we do create a three-dimensional object out of these surfaces. And then once we go into Twinmotion, it's going to be a lot easier to apply these materials. So how do we do that? Well, it means that we're going to have to explode our entire model and then go kind of wall by wall or surface by surface, material by material, and join the pieces together. Okay. It sounds like a lot of work. It's not that bad. Once you get into the rhythm of it, it kind of goes pretty quickly. However, there's two things, okay, that we have to keep in mind. And that is that one, you always wanted, when we're going into rendering, you always want to know who is your audience. What are you doing the rendering for? Are you just doing a still image? Are you doing an animation, a fly-through animation? Because that's going to determine exactly how much kind of time and effort you want to put into the model. Not effort, but how detailed do you want to get into it, right? So in other words, if I'm doing a still image and let's say I'm going to do this kind of money shot render and it's only this view here, well, then there's real no point in me spending any time on any of these surfaces back here, right? Or putting time in getting my detailing or doing these Boolean union or joining the geometry on a staircase if it's never going to be seen. So we want to work smart. We want to be efficient with our time. So you want to know exactly kind of where are my rendering spots. So that's something you could decide right now. However, if you're going to do a fly through animation, and the same would apply. Where are you flying through? Maybe I don't need to add any detail into these bathrooms or into the closet space, right? You could figure out where is the fly through going to happen so that you know where to kind of put your time and energy. Now, if you're doing a full-on kind of virtual reality with a headset and you're going to let people walk through the structure, then yes, you're going to have to go ahead and dedicate all the time to work out all of the details and all the little nooks and crannies just because you know people are going to be walking in through these spaces. So that's rule number one. Know your audience, know what it is that you're going to actually show in the render. The second thing is when we render or when we go into Twinmotion, and this is true for almost any rendering software, whether it's Twinmotion or V-Ray or Enscape, whichever one it is, the way that materials get applied, think of it as a picture that gets slapped onto that surface. Okay? That's in theory kind of how it works. However, that gets a little bit more complicated when you start to try to slap a picture on an angle, right? Um, because it doesn't register this angle, or it takes a little bit more energy to register an angle. It gets even more complicated when trying to register multiple angles on multiple surfaces. Okay, that becomes really tricky. And if you have a material that has all sorts of bends and cuts from different angles, then that becomes really difficult. And we end up having to adjust the material and we end up having to kind of play around with the what we call the UV settings of the material. And it gets really challenging. So one thing we can do to simplify that is just to keep our geometry and how we're unioning and creating the geometry for our materials as simple kind of forms. So keep it as a simple square, keep it as a simple surface, or a circle, or a sphere, or if you're going to do weird angles, maybe you do multiple individual surfaces as opposed to one general surface. Okay. We'll talk about that a little bit more as we're kind of going along here. So let's go ahead and get started. I'm going to go back into shaded view. Okay? And this is going to hurt, but we're going to have to explode everything. Now, before we do this, rendering typically should happen at the very end of the design process. So once we know that we're not going to make any more changes, we can make some minor changes, but because we're going to have to go through this process of exploding, we're probably not going to want to make any kind of significant changes from here on out. One thing that you can do is go up to File, Save As, and then save your file as a separate file and call it, I don't know what I have, two-story residence walls for rendering. Okay, so now you have the actual working model where everything is still unioned and joined together correctly the way Rhino likes it. But now you have a separate file that is kind of exploded and set up for Twinmotion or for your rendering software. So that if you ever need to go back to the actual geometry or to the actual Rhino file, you could always go back to the original file. So you might want to do that moving forward. So make sure to save your file as and create a separate file for your rendering. Okay, so the next step is I'm going to go ahead and start exploding my walls. Actually, let's go in and start hiding everything or turning off these layers, the guardrails. So now I only have my walls. Okay. And then I'm going to go ahead and actually let's focus on our first floor walls. Okay, so what I'm going to do is take this and I'm going to explode it. And now I have individual surfaces. Okay. So now that I have these individual surfaces, this is what I mean that Twinmotion will not apply material to this individual surface unless, well, I hold down the Shift key and I select both of these and I union them. So now when I click on it, these two surfaces are unioned together, and therefore Twinmotion will be able to apply material to them. Okay. So I want to also kind of think, where do I want, what's going to have the same material? Okay. So chances are I'm probably going to want all of this exterior to be the same material. If you think Well, maybe this is going to be a brick and this backside will be a stucco color. Then let's union these two separately. Okay, so now this is unioned as one and this is unioned as another. So this way I could apply material here and it'll apply to all of these surfaces. Okay, if I union all four of them together, then when I place the brick material, it'll apply the material to all four surfaces. Okay, and this gets a little bit easier as we with experience. But then we have the issue of um, actually, let's talk about the interior. The same would apply here on the interior side. So if I want this, let's say I want these four or these three walls, and actually all of these here. Oh, that needs to be exploded. So let's go in. Now I could leave it because remember that Twinmotion will apply material to the individual surfaces or to an actual geometry. So I could leave it, but I might want the bathroom to be a different color. So in that sense, I might want this side to be maybe a white, while the inside to be, I don't know, pick your color, right? So that's why we're exploding it. So if I select this and this and this and this, now this is where the stair is. So maybe that I want that to be an accent wall. So I'm gonna probably want that to be a separate um, material. Okay. So I could join these together and sorry, not joining, Boolean union them. So when I click on it, it's all joined together as one. Okay. Now the nice thing too is that in Twinmotion, it's fairly simple to make changes. So we're gonna link Rhino to Twinmotion. So if we go in and we apply material and we say, you know what, never mind, I actually want this accent wall to kind of bleed over to this side of the wall, then we could come back into Rhino, explode the material, reunion them together appropriately, and then link the Rhino file or relink the Rhino file into Twinmotion, and in Twinmotion we'll be able to make these changes really seamlessly. So right now, don't think anything is permanent. Um, we're just kind of taking a stab at everything, and then if we need to make changes, we can make changes afterwards as well. Okay. Okay, but now I have my accent wall. Now remember what the rule was that everything Twinmotion can apply material to a poly surface, so a three-dimensional object like this, or to surfaces that have been unioned together. That's it. So what happens here? What happens with this where it's only a surface? I don't want to join it to the entire wall because then I'm not going to be able to have a separate material on the exterior side. Okay. So if you ever find yourself in a situation where you only have a surface, well, we could always make this a poly surface. We could always turn this into a three-dimensional object. Okay. We do that by giving it a thickness. Now, we don't have to give it a full 10 feet thickness. We can pretty much specify whatever thickness we want. So we could even go down to just say a quarter of an inch, an eighth of an inch. So something really tiny, but that will turn it into a poly surface. Okay, so that's what I'm going to do. I'm going to select this surface and I'm going to type in extrude surf, which is extrude surface. I'll hit enter. Well, you should type it correctly and not misspell it. There we go. Extrude surf. There we go. Um, I'm going to make sure that solid is set to yes, because we do want it to be a closed poly surface. And I'm going to come out this way, and I'm just going to type in a quarter inch, enter. Now, when I zoom in, I could see that it has a thickness, right? So there we have an actual three-dimensional poly surface that we could apply a material to. I do want to put it back in its correct layer. So I'm going to select it and put it right here. And there we go. Okay. Then we run into the problem of the inside sills, and these are always really annoying. what material is it going to have? So we talked about maybe a brick on the outside and maybe a painted color on the inside. Well, what happens here? Okay. We have our windows. So let's bring our windows in for a minute. Now, when I'm on the inside, I'm going to want this to be white. But if I paint this white, then it's going to be white on this side where I have the brick. And I'm actually going to want to see the brick on this side. Okay. So what we have to do, and again, this goes back to my comment of who's your audience? What are you trying to do? Do you really need to go into this level of detail? Is it going to be seen? Those type of things. If it is going to be seen and you do want to show it, then what we have to do is split the surface. Okay. And the way we're going to do that is by using the rectangle tool. Let's get into the default layer, sorry. And we're going to do vertical, click there, and bring this down. And then I'm going to move this to the center. Then I'll select, holding down the Shift key, select all of these surfaces. And then I'm going to use the split command. So I'm going to type in split, enter, select cutting objects. I want to use this rectangle line as a cutting object, and I'll hit enter. And now it has split this surface. So I could go in and I can delete my curve, and I can select these and Boolean union them. I could select these and Boolean union them. Now in theory, I should be able to select this Boolean union and this Boolean union and Boolean union both of these as one, so that when I apply the material, it gets applied to this surface and this surface because it's going to be the same material. However, that's where it gets complicated. Remember what I was saying that when we apply materials, we want to keep it as kind of simple geometry, squares, rectangles, spheres, circles, things like that. The more bends and cuts and corners you end up having, the harder the rendering software has to work in trying to map the actual image and how does it bend, right? So if you imagine if you had to glue an image to this exterior wall, but now you have to cut it so that you can overlap or so you could bend it so that it could fit in these seams, right? And if you do that multiple times over here, and you also have to do it over here, and you have to do it over here, and over here, and over here, at some point, the rendering software is just not going to get it right. It's going to start to warp. The material is going to start to kind of come in at an angle. It gets more and more complicated. So we want to keep this as simple as possible. The nice thing is that when we get into Twinmotion, applying a material is going to be as simple as drag and drop, drag and drop. So it's not a whole lot of work to add a material here and a material there and a material there. Um, but it's going to give you the flexibility to really apply the material or to get the material to look correct. Okay, so we have to split that object. I'll do that one more time. We'll go vertical. I'm actually going to have to do that quite a bit, but I'm not going to put you through that. I'm not going to make you see that. So let's move this, move it to the center, select the four surfaces. Oh, not this one. Make sure that we're clicking on the correct one. So I'm holding down the control key to deselect, and then shift is to multiple selection. So then I'll type in split, click on the arrow, hit enter, go in and delete the curve, and now join. I shouldn't say join. Boolean union those surfaces together. Make sure you're unioning the correct one. So this is where it gets really tricky. You have to really pay attention to make sure that you're not accidentally clicking the wrong one. Okay. There we go. Okay. So the same thing with the door, right? I'm going to go ahead and split all of my surfaces, all of these kind of windowsill portions, along with the door. Um, And then what I'm also going to do is do the same thing up here. I'm going to have to explode my second floor, union all of the exterior, union all of the interior rooms. I'll go ahead and union all of these interiors together, and so on. Okay. But I'm going to go ahead and pause the recording so you're not having to watch me do that. Okay, so I came to this wall right now. I was going around and doing all of the individual um, Boolean unions, and I came across this one, right? We made this one a individual poly surface, but how do I split this? Because remember, I'm going to have that window right here. So I could do a couple of different things, but essentially I want to do the Boolean difference here. So the way I'm going to do that is just I'm actually going to extrude the surface, this side surface. So let's go extrude surf, select, nope, not that surface. Let me do that again. Extrude surf, and I'm going to select this side right there, that one. And I'm going to hit enter, solid set to yes, and I'm going to want to go up to the midpoint. So now I have two surfaces overlapping, and I could use the Boolean difference, select that surface, hit enter, then select this surface, hit enter, and now that cut my poly surface. That cut that little surface right there. And at this point, I can go ahead and draw my line from there to there. Technically, I could just leave it as is because once I apply the material to this surface, I'm going to apply a different material over here. So we're not going to see anything that's behind this surface. But just to keep it simple and correct, I'm going to take that surface, split it with the line I just created. Okay. And now we have that poly surface right there. Okay. And then from here, I'll go ahead and use the rectangle. Actually, I could have just used the rectangle tool for the entire thing. Um, but I'll go ahead and follow through and split it. So I just want to show you how to kind of go about kind of these little weird moments that need kind of additional readjusting. All right, I'm going to keep knocking away at this. Okay, so I've now unioned my surfaces all throughout the first floor and the second floor. Um, I'm going to be honest, I did not split the sills here, but what I ended up doing was just making them all as one. And I did that just for efficiency, so I could get it done a lot faster, also known as just being lazy. Um, However, everything is done. So all the exteriors are unioned together. These interior rooms are unioned together. Okay. So this way I could go in and apply different materials to the bedrooms or the bathrooms, however I want to. Okay. And I did nothing to these posts because, again, these are three-dimensional objects. These are three-dimensional poly surfaces, and we could apply material to them. Now, if I wanted to apply material just to two sides, then I'd have to explode them and join a union the two sides and so on. Okay, so we have the walls done. Now let's talk about the windows. What'll so right now the glass is a three-dimensional object, so not everything needs to be exploded. You have to think about what about the material, or the material, does material get applied to all of the surfaces, right? So it didn't make sense in the walls because we wanted one material on the exterior and a different material on the interior. But on the glass, it's glass on both sides of the object. So we could actually just leave it as is. And the same with the frame, with the window frame. It's going to be metal on one side and it's going to be metal on the inside. So it doesn't matter. So in that case, a three-dimensional poly surface, we could just leave it as is. And that's true with anything that you have in here. So that's also going to be true for, let's say, our guardrails. Okay. The material can be the same throughout. That's fine. The same with like the stairs. Um, we could apply material here, and these are all going to be the materials the same throughout. Now, with the staircase, if we wanted a different material on the underside, then we would have to explode this and just churn that surface, give it a little thickness for a different material, and then join Boolean union all of the steps. But I'm going to leave it as is for now. Huh. So if we don't have to do anything to the windows, the same with our doors. Our windows are done, the walls are done, the doors are done, the stairs are done. Sorry. The guardrails are done. All right, let's talk about the floor. And for this, we kind of need to talk about we need to bring in our walls. Okay. So with the floors, it's going to be the same kind of conversation, right? Is the floor going to be the same throughout the building? If yes, then we don't have to divide the top layer. Okay. However, look at what happens on the outside. If I apply a wood floor on the inside, that wood flooring is going to be applied out here. When in reality, this wood flooring should actually be applied with the same material that we have on the exterior, right? So if this is brick, that too should be brick. So what I'm going to do here, now this I imagine to be concrete, and it'll be concrete throughout. But this one, I'm going to want to explode. Okay. I'm going to want that and that surface, not this one. Trying to see if I could just, there we go, select that one. I held down the shift key and it clicked right on the line. So that's probably going to be the same material. Now I'm thinking that this side of the exterior is going to be brick and the other side might be a different material. So I'm going to union these two together. And I'm going to union these two together. Okay. Now that leaves me with just a top surface. And we've talked about that Twinmotion does not apply material to just a single surface. So we need to give this a thickness. Now this is where it gets a little, we just have to kind of think a little bit ahead. We know that we have to extrude it, right? We have to give it a thickness. We have to make it a three-dimensional poly surface. So let's go ahead and extrude surf and make sure solid is set to yes. Now the question is, do we extrude upward or do we extrude downward? Okay. And this is where you kind of have to think, if I extrude up, then it's going to disrupt my floor to ceiling height, right? Is that a problem? Do we care about that? Do we not? Maybe we don't care, and so we extrude up. But also understand that we could also extrude down. And if we extrude down, then it keeps the top surface at the same height, and we don't do anything in as far as changing the height, right? And if we extrude downward, it doesn't really matter because it's going to go into nothing. So I'm going to come down on this one. And again, I'm just going to go like a quarter of an inch down. Okay. And I could see here, there we go. Oops, there's the poly surface. Okay. Now we might get a sliver of a line in the render for that. So if we wanted to, we can, um, we could do the same thing we did over here to this window, right? Where we do the Boolean difference and we cut that little portion off. We could do that as well, but I'm going to leave it as is for now, and we'll see what that looks like in the Twinmotion if it's something I want to adjust later on. I'm hoping that maybe we don't see it. Okay. Now over here, I'm going to want to do the same thing. Now that right now this is already exploded, so I'm just going to union all four of these sides. Okay. And then I'm going to, let's see, uh, perhaps we want to make, let's go ahead and make, we'll go ahead and bring this down or extrude surf down. And we'll do the same thing. This time, I'm just going to try 1/8 of an inch. We're not going to go deep. So 1/8 of an inch. Okay. So now I could apply material here. What happens if I want to change the material? What if I want the bathrooms to have a tile or a bedroom carpeting? Well, what I can do is just create another three-dimensional poly surface. So I'm going to use the rectangle tool and click there. I'm going to do that again over here on this side and click there. And I'll go ahead and select that curve and extrude curve, not surface, curve. Make sure that solid is set to yes, because it has to be a closed solid. And we're going to go up 1/4 of an inch. Enter. Do the same thing over here. We're going to go up 1/4 of an inch. There we go. So when I zoom in, I could see that it's there. So this way I can apply, let's say, a hardwood material here and then the tile above it. Okay, and because the tile is above the hardwood, we're not going to see that there's actually going to be hardwood underneath that surface. Now, if we wanted to apply it into the room, into the bedroom, then we'd go ahead and use our poly surface line and trace all around the bedroom and then extrude curve that line into a thickness. And then that means we could apply a carpet or something like that. Okay. Now we have to make sure not to forget about ceiling here. Okay. So we have this ceiling right there. So I'm going to extrude surface because it's the surface. I'm going to bring that down. Let's also go 1/8 of an inch. Make sure solid is set to yes. There we go. Okay. So now we have our floors in place. Now at this point, we do have a surface and a poly surface, right? When we extrude a surface, it actually keeps that original surface there. Um, that's why we are seeing two. At this point, when we go into Twinmotion isn't going to register the surface. So it's going to just not show it to you. So that's not going to be a problem. We can leave it as is. But if you want a cleaner model, we can select it and just hit the delete key so that when we click, we know exactly what we're clicking on. Okay. But again, that's not necessary. That's not required. All right. The last step is going to be our roofs. Now, roofs again are going to be a little bit tricky because remember what I said about slapping the image? That's how we create these renders. Or that's how rendering softwares, they take an image and they wrap it around an object, but that gets complicated when we start doing angles. Okay. And the more angles it has, the more kind of complicated it is. So in this situation, we want to simplify it so that we have full control just on a simple object. Okay. We could still have control over these 4 planes, but it's going to get really complicated. And sometimes we end up having to just kind of break it all up anyways. So let's start off with this one. This one's going to be easier. For this one, we're going to do the same thing, explode it. And in this situation, I'm going to want to be able to paint the fascia boards. So I'm going to union them. And here we have that situation where we only have a single surface. Okay, so if it's only a single surface, we can't Boolean union it, then we're going to extrude curve or extrude surface. Sorry, we're going to extrude it. We're going to give it a thickness. Now this is a roofing material, so I might actually want to see a little thickness on this one. So I'm going to go give it 3/4 of an inch thick, and I'm just making these numbers up. There's no real reason here. Okay, so now I have a little bit more of a thickness there. Now with this one, we're going to do the same thing. I'm going to select it, explode it, and I'm going to union all of these. Okay. Remember, I said that we want to try to simplify, right? The union so that when we map the images onto the surfaces, we want to keep it simple geometry, so squares, cubes, circles, cylinders, spheres, things like that. This technically is still a square, so that's not a problem. That's not going to be a problem. If we start trying to union it with another angle at this point, or having it kind of dip down, or like other edges and things like that, that's when it gets a bit more complicated. And so let's union this. So now in theory, I should be able to select all 4 surfaces and union them. But this is one of those situations that because it's a weird angle, instead what I'm going to do is treat them like I did here and give them each individual thicknesses so I could apply the material individually to each one and adjust it, um, adjust the mapping, the angle of the image if I need to. Okay. So I'm going to select all four and I'm going to use extrude surf. And I'm actually going to extrude all of them at the same time. So I'm going to extrude the same as the first floor roof, 3/4 of an inch. Make sure solid is set to yes, and I'm going to hit enter. So now I have a thickness. Okay. And think, I think I'm done. Let's see. At this point, everything it should be done. Now, the one thing is, again, if we need to make changes down the line, we could always come back to our Rhino model if we need to. Okay. It's not going to be a problem. One last thing. This is somewhat important. If you want, at this point, you could begin to add Rhino materials to your objects. Okay. You could actually apply these materials directly to the object itself, and Twinmotion will actually sorry, what am I trying to say? Twinmotion will actually register objects with the same material. So here, I keep clicking on the glass. Right now, in Rhino, I already have the glass here. Okay, I already have the material set for the window frame. So right now, or up until now, we've been talking about setting materials to individual objects. Okay. But there also in Twinmotion is an option where you can select a material um, or apply a material to something that already has a material assigned to it, and it'll do it for all of the same material. So in other words, you'll see right now that I have all the glass selected, or already the glass material in, I can go into Twinmotion and drag and drop glass material directly just on one single piece of glass, and it'll apply that same material to everything that shares the Rhino material. I'll be able to apply a aluminum metal to the frame, and it'll apply the aluminum metal to any material or any object that has the Rhino aluminum metal. Hopefully that makes sense. If not, it'll make sense once we get into Twinmotion. Okay. But for now, that's how we prep the file um, and get it ready for Twinmotion. Good luck, everyone.